All right, so today we're going to be talking about operations with polynomials. So the first thing that we're going to start off with are a few definitions. A monomial is a number, a variable, or an expression that is the product of one or more variables with non-negative integer exponents. Okay, so this part that's underlined in red here is very important. Non-negative integer exponents. Okay, so if it has a negative exponent or if it has a fraction exponent, anything like that, it's not considered to be a monomial. A polynomial consists of monomials that are being added or subtracted. So if something has a term in it that's not a monomial, it's not considered a polynomial either. And the last vocabulary word that we're going to talk about today is the degree of a polynomial. The degree of a polynomial is the degree or the largest exponent of the monomial with the greatest degree. So you look for the term that has the highest exponent, and that highest exponent is the degree of the polynomial. So the first thing that we're going to do with these definitions is we're going to determine whether the expressions shown below are polynomials. Okay, so if they're made up of monomials. If it is, we're going to state the degree of that polynomial. So the first example we have says 1/4 x to the fourth y to the third minus 8x to the fifth. Okay, now remember, in order for something to be a monomial, what we're looking for are non-negative integer exponents. Our only exponents here are 4, 3, and 5, and all of those are non-negative and integers, so this is a polynomial. Okay, and because it is a polynomial, the next thing we need to do is find the degree. Okay, so remember, our degree is our largest exponent. When you have a monomial with two variables like this, you add the two exponents together to get your degree. Okay, so for this one, 4 plus 3, that's 7, and 7 is greater than 5, so our degree is 7, the largest exponent. Okay, the next example, example B, says the square root of x plus 4. Because the square root of x is not technically a non-negative integer exponent, it's to the power of 1/2, it is not a polynomial. So no, it's not a polynomial. Since it's not a polynomial, we are not going to find a degree for it. The next one we have is x to the power of -3 plus 2x to the power of -2 plus 6. Okay, so remember, again, we need non-negative integer exponents. If you notice, both of those exponents right there are negative. So this is not a polynomial either. Okay, and since it's not a polynomial, we don't need to find the degree. The last example we have is 2x squared minus 8x cubed plus 1/5 x to the sixth. All of those exponents are non-negative and integers, so it is a polynomial. And since it is a polynomial, we can find the degree. All right, now again, remember your degree is your largest exponent. So if I look at all of those terms, I can see my largest exponent is 6. So the degree of this polynomial is 6. The last thing that we're going to do with these polynomials in this video are simplifying polynomial expressions, so the actual operations with polynomials. Okay, now the first operation we're going to look at is addition. Addition with polynomials is just like combining like terms. So I look at the two polynomials and I see what I can combine. My first term is 4x squared. I can combine 4x squared with 2x squared. Okay, so 4x squared plus 2x squared is going to give me a 6x squared. Okay, the next term is -5x. -5x can be combined with 3x. -5x plus 3x is -2x. And then my last term is 6 in the first polynomial. 6 can be combined with -1. 6 minus 1 is going to give me a +5. Okay, so addition is just combining like terms. Subtraction is very similar to that, but I have to pay attention to that negative sign. So again, I'm going to look for my like terms. 6x squared can be combined with -4x squared. But this is 6x squared minus negative 4x squared. And when you subtract the negative, it turns to a positive. So 6x squared plus 4x squared is going to give me a 10x squared. Then I'm going to do the same thing with my next term. Okay, so my next one is negative 7x. I can combine that with 9x. So negative 7x minus 9x is a negative 16x. Okay, then I'm going to do my last term. 8 can be combined with negative 5. But again, you have to be careful. It's 8 minus negative 5. Minus a negative, again, turns to a positive. So 8 plus 5 is going to give us a positive 13. Since nothing else can be combined in that, we are done. All right, so addition and subtraction are combining like terms. We just have to pay attention to our signs. The next operation we're going to look at is multiplication. Now, this first one is just a single monomial times a polynomial. So for this, all we're going to do is distribute this 3x out front. So 3x times 2x squared is going to give us a 6x to the power of 3. 3x times negative 4x is going to give us negative 12x squared. And last, 3x times 6 is going to give us a positive 18x. Since none of those terms can be combined, we're done with that problem. 6x cubed minus 12x squared plus 18x. The last one is very similar to that, but because we have a binomial times a trinomial, we can't just distribute it in the same way. What we'll have to do is distribute both of these terms to all of these terms like this. Now, we can do it just like that, but for problems like this, I like to create a box so I don't get confused. So in my box, I'm going to have a 2 by 3 box. So I'm going to have 2 terms, which represents my n and 2, and then I have 3 terms, which is my n squared plus 4n minus 6. Now, inside my box, I'm just going to multiply. So n squared times n is n to the third. 4n times n is 4n squared. Negative 6 times n is negative 6n. Okay, then I'm going to do the same thing. N squared times 2 is 2n squared. 4n times 2 is 8n. And negative 6 times 2 is negative 12. Now, I need to combine like terms, but I can do that in my box. Okay, so if you notice, I can combine 4n squared and 2n squared, and I can combine negative 6n and 8n. Then I just write out what that gives me. So my first term, I'm going to bring down from right here, is n cubed. 4n squared plus 2n squared is going to give me 6n squared. Negative 6n plus 8n is going to give me a positive 2n, and then I'm left with this negative 12. Now, if I look at that, n cubed plus 6n squared plus 2n minus 12, I can't combine any of those, so that's my final answer. Okay, and that concludes the first video. I'll make a second video to review the exponent rules. I just didn't want to make the 2 videos super long.